This video series is all about examples using the metric system. So as a quick intro, remember that your metric prefixes are going to represent powers of 10. And when we use the equalities for metric prefixes, we always want to put 1 next to the unit with the prefix in an equality that contains the base unit. So in the metric system, we have 3 types of base units that we'll look at. Length is the meter, represented by lowercase m. Mass is the gram, which is a lowercase g abbreviation. And volume is the liter, which is a capital L as its abbreviation. So the most common 5 metric prefixes that we use in General Chemistry 1, and this is not a comprehensive list, okay, so your instructor may have you memorize more than the 5 listed. But the 5 most common are the kilo, which represents 10 to the 3rd power. Centi represents 10 to the negative 2nd. Milli, 10 to the negative 3rd. Micro, 10 to the negative 6th. And nano, 10 to the negative 9th. Okay, so in our first example problem, we're going to give the name of the prefix and an example equality statement using the SI base unit for length. So remember that the base unit for length is the meter, which is represented by that lowercase m. Okay, so what we need is the lowercase m for this. Now, a lowercase c represents centi. And so if we want to create an equality statement with the meter using the centi prefix, remember that we're always going to put 1 next to the prefix unit, so 1 centimeter is equal to, and then remember for centi, our base was a 10 to the negative 2. Okay, so we've got 1 times 10 to the negative 2nd power, and the unit next to that of the power of 10 should always be your base, which in this case is the meter. Okay, next example, we've got the micro prefix. That could be represented by the Greek symbol mu, or it could be represented by a lowercase mc. But that is our micro prefix. Okay, and so we would have 1 micrometer is equal to 1 times 10, and again, the micro is 10 to the negative 6th. So 1 times 10 to the negative 6th, and then our base unit here is always the meter. Now just keep in mind that you can change out that base unit. So one quick example with the centi, we could have 1 centigram is equal to 1 times 10 to the negative 2nd gram. So notice what's always consistent here is you have the 1 and the prefix, and you have the same power for that prefix. And then you can change out that base unit for anything. Okay, K represents the kilo. So there we've got 1 kilometer is equal to 1 times 10, and for kilo, it was raised to the power of 3. 1 times 10 to the 3rd meters. Okay, so notice that of all the 5 that we talked about, kilo is the one that is positive. It is the prefix that represents a greater value than the base unit. All the other ones that we look at that are most common in chemistry are going to represent smaller units. Milli is, or lowercase m is your milli prefix, and that's going to be 1 millimeter equals 1 times 10 to the negative 3rd meters. So it's kind of the opposite of the kilo. And our last one, N, of course, represents nano. And so 1 nanometer is equal to 1 times 10 to the negative 9th meters. Okay, so those are your 5 most common prefixes, and those are examples of how you can represent them in equalities. Now, the next thing we're going to talk about is how to convert between a prefix and the base unit. And to do that, we want to take a second to talk about conversion factors, right? So metric conversions are going to be equality statements, and those can be converted into fractions. But remember that when we're looking at these equality statements and we're trying to create fractions, that we cannot separate the number from the unit. So in the example that I have here, we've got 1 milligram. That 1 has to stay with that milligram. Okay, so we can't separate those. And then we've got 10 to the negative third grams. Now, depending, you could say 1 times 10 to the negative third grams. Sometimes I find the 1 times 10 to the negative third more useful when you're using scientific notation in your calculator, which we'll talk about in different videos. But the main thing is that when you have a number next to that unit, it has to stay together. Okay, so if I want to create a conversion factor using the equality that I'm given, I'm going to choose to put the 1 milligram on top. And if I do that, that forces the other side of the equality, the 10 to the negative third grams, to go on the bottom. Okay, so notice how, again, those numbers and those units are staying together. So this is what we call a conversion factor. And we will use those often in chemistry. And another statement that you'll hear me say in the videos constantly is, do we want to keep or flip? All right, so do I want to keep that conversion factor as written, or do I want to flip it so that the 10 to the negative third grams are on top and the 1 milligram is on the bottom? Okay, and the way that I'm going to decide that is based on what are my given units and what are my target units. So we're going to use what are called roadmaps, and these will show the individual steps and conversion factors that we need to solve a problem. Okay, so in general, when we're looking at a one-step conversion factor roadmap, we're going to start out with the given information, and we're going to end with the target. And underneath our arrows, a lot of times we will include the conversion factors. Okay. Now, in general, a general rule for conversion factors is that we want to typically have the target units on the top and the given units on the bottom for each step. Okay, so let's look at some examples of this. We want to complete the following conversions between SI units. So we're given the meters and asked to find the centimeters. So if we set this up as a roadmap, we're going to get 8.160 meters and an arrow going towards our target, which are the centimeters. And then underneath that, we're going to put a conversion factor, and sometimes it may help to write it out just as an equality, and then we can create the fraction whenever we're writing out the problem. So I need an equality that has both the meters and the centimeters. And so that's why it's important to memorize the equality that we have for every 1 centimeter is equal to 1 times 10 to the negative second meters. So once we've got our roadmap with our equality, we can set up our unit conversion where we start with the given information, 8.160 meters, and multiply it by our conversion factor. And remember, that's going to come from our equality where we want to have the target units on the top. So we're trying to get to centimeters. That means that from the equality, we want to use the 1 centimeter. And then underneath, we'll have the given units coming from that equality, which is 1 times 10 to the negative second meters. Now, if you need help plugging scientific notation into a calculator and how to use that double E key, just watch one of my previous videos on scientific notation. Okay, so we're going to cross out the meters because they are opposite, right? We've got one on top, one on bottom, so they cancel out. And then we're left with 816.6 0.0 centimeters as our final answer. And also check out the videos on significant figures if you need help understanding why we included that 0 at the end. Okay, now on the second option, or the second example, we've got 3,779 micrograms. We want to convert that into grams. So again, we're going to create a simple roadmap where we're given micrograms and we want to find the grams. Okay, and underneath that arrow, we're going to include the equality that takes us from the microgram to the gram. So we know 1 microgram is equal to 1 times 10 to the negative 6th grams. Okay, so starting with our given information, we've got that 3,779 micrograms. Multiply by our conversion factor. Again, we want to put the target units on top from our equality. So if the target is the gram, then from our equality, we want to use the 1 times 10 to the negative 6th grams on top, which forces the 1 microgram from the equality to go on the bottom. And then the microgram units can cancel because we've got them on top and on bottom of a fraction. Okay, and then plug this into your calculator, and you should get back 3.779 times 10 to the negative 6th grams. Okay, so we got 2 more examples. I recommend that you pause the video and try to work these out yourself. We've got 781 milliliters and trying to find what is that in liters. Our equality between the milliliter and the liter is that 1 milliliter is equal to 1 times 10 to the negative 3rd liters. We start out with the 781 milliliters, multiply by conversion factor, and remember we want to take from the equality the target units first. So if we're trying to get to liters, then the equality statement, we're going to put the 1 times 10 to the negative 3rd liters on top, and then the 1 milliliter on bottom. Notice how the conversion factor is always created strictly from the equality that I write underneath the arrow. The milliliters cancel, top and bottom, and then in your calculator you should get back 0.781 liters. Okay, and then in the last example, 27.8 meters. Trying to figure out what that is in kilometers. And we know that 1 kilometer is equal to 1 times 10 to the 3rd meters. Remember, that is the one prefix that we use that is larger than the base unit. Okay, so we're going to start out with that given information, 27.8 meters, multiply, and then we use our equality, and we always want the target units from the equality on top. So if our target is the kilometer, then we're going to put 1 kilometer from the equality on top, and then underneath 1 times 10 to the 3rd meters. Meters cancel, and we get back 0.0278 kilometers. Now, keep in mind something, a nice trick to know is that if you're going from a smaller unit to a larger unit, then the number should get smaller, right? Okay, so milliliter is a smaller unit than the liter, which is the larger unit. And so when we go from a smaller to a larger unit, you'll notice that we go from a larger number to a smaller number. So they're kind of opposite. And you see the same thing happen. The meter is smaller than the kilometer, and so you'll see that number get smaller as we go from the meter to the kilometer. And then, of course, the opposite will happen if we start out with a larger unit going to a smaller unit. You'll see that number get bigger, like what we saw here with the meter to the centimeter. All right, that wraps up this section.